This is the Cordy Integraph, made in 1903 in Zurich. The purpose of this intriguing device is to graphically and numerically find integrals from a curve drawn on paper. The Integraph works mechanically by using a stylus to trace the curve. The stylus is mechanically linked to a pencil that traces a curve on paper. Suppose we have a drawing of a function y of x on a piece of paper. The definite integral of the function is capital Y of x, which is the area of y of x between a starting point x1 and a point x. The first theorem of integral calculus says capital Y of x is equal to a function f of x evaluated at x minus the function evaluated at x1. Then, the derivative of capital Y, evaluated at the point x, is equal to the derivative of the function f, evaluated at the point x, which is equal to the function y of x from the first theorem. The Integraph mechanically finds the derivative of capital Y of x, evaluated at the point x, from y of x. The way it works is like this. The stylus, which you trace along the curve, extends a distance b from the axle of the device. The mechanical linkage sets the angle of the wheel on the tracing pencil at a slope proportional to the vertical distance between the stylus and the reference line. The wheel encodes the derivative of capital Y of x, which is equal to little y, the slope of the curve of capital Y at the point x. As the Integraph rolls forward, the pencil traces out capital Y of x, which is the integral of little y of x. This produces a curve whose slope at every point is little y, which is the definite integral of little y. The Integraph also produces numerical output that can be accurate to better than 2 digits. There are 2 veneers on the device. The first veneer sets b, the distance the stylus extends from the center axis of the device. The vernier works by setting the first 2 digits on the scale, for example 6.0. The final digit is found by lining up the vernier scale, in this case giving 6.04 centimeters, with the previous digit. Carefully done, this can be done to 3 digits of precision. The second veneer is proportional to capital Y and works in the same way. Let's integrate 1 over x. The integral of 1 over x is starting at 1 to the point x is the natural logarithm of x. The integral has to start at 1, and let's find log of 10. So we'll end at x equals 10. Start by locking the stylus knob at 0 using the x knob, and running the stylus on the x-axis to ensure that the Integraph is properly aligned with the graph. Now release the stylus and put the stylus at the start of the curve, and record the starting position of the Y vernier. Move the stylus carefully along the curve, and the pencil will trace out the integral. The motion has to be slow, so that the small wheel does not skid on the vellum. Even with soft lead, the pencil line is faint, but can be traced later. At the end, read off the final value of the vernier. The Integraph has produced a curve on x and the value. We have 3-digit values for y at the start and finish, but the y-axis still needs to be calibrated to the graph for y. The Integraph verniers are in both centimeters and inches. We will use centimeters. The x-axis in the curve, just integrated, is 1.9 centimeters per unit, and the y-axis is 11.7 centimeters per unit. If the integraph were used to integrate y equals 1 over the interval x equals 0 to 1, that would give capital Y equal 1 unit. In terms of centimeters, the slope the wheel makes is b divided by small b, where b is the calibration of the y-axis. The integraph moves forward by 1.9 inches, so in centimeters, capital Y has changed by b divided by small b times the distance moved in centimeters, which is a, and this corresponds to 1 unit along capital Y. The conversion factor from the y vernier to the units in the graph is then just small b divided by the product a times b. Applying this to the values we just measured, the ending value was 5.32 centimeters. The starting value was 7.34 centimeters, so the change in y was 7.98 centimeters. The calibration of the x-axis, A, was 1.9 centimeters per unit, B, 11.7 centimeters per unit, which is the calibration of y, and the distance of the stylus, small b, was 6.0 centimeters, which gives a conversion factor of 0.272. Our measured value for log 10 is then 7.98 times 0.272, which is 2.17. The actual value is 2.30, which is 5% different. The Corti Integraph is a remarkable device able to carry out complex mathematics through a simple arrangements of wheels, rods, and verniers. I hope you have found it as interesting as I have.